Okay, we're now moving on to 3D trigonometry, and again, a bit like 3D Pythagoras, it's really important that you've seen this stuff before. You've seen the SOHCAHTOA, you've seen the equation triangles, or however you do it. But I like to use equation triangles, and you're familiar with grade 5 trigonometry because really 3D trigonometry is just applying what you know at grade 5 in 3 dimensions. Okay, so I'll leave a link to the video below on grade 5 trigonometry that you can watch before doing this if you need to. But if you've seen that and you're confident with trigonometry at grade 5, we are ready to begin by looking at trigonometry in 3 dimensions. So 3D trig is just applying what you know about trigonometry in 3D. So again, a bit like with 3D Pythagoras, you're given 3D objects like a cuboid here, and you might be asked to find perhaps a missing angle, not in this case, or a missing side, okay, within a triangle in 3 dimensions. So what we're going to do is we're going to look at sorry, it also says that you might also need to use 3D Pythagoras in 3D trigonometry problems. Okay? We're going to go through a couple of examples, 2 examples in fact, and then you can try a couple of questions yourself afterwards. Okay? So example 1 says, shown below is a cube, and that's an important word because that's going to mean that every single side length is going to be equal to 5, because in a cube, every side is the same. And it says, find angle CAG to 1 decimal place. Well, okay, first of all, right, CAG, we've got CA up to G. Here we go again. So, right, I've got C to A to G. Angle CAG, the middle one, is the one that you're interested in. So, CAG, A is this angle here. Okay? And this triangle, let's go and draw it down below here. And again, let's label up the triangle that I've got. So, I've got A to C, which is down here. And I've got the point G, which is up here. And importantly, right, because trigonometry, I need a right angle for this stuff. So I've got a right angle here because I've got a vertical side meeting a flat surface. So at the point C, I've got a right angle. I'm trying to find this angle, CAG, so which is over here. So let's go and call this angle, let's go and call it theta, the angle. Okay, no, in fact, let's go and call it angle X. Angle X, okay? What else do I know in this triangle? I know that this bit, C to G, must be 5 centimeters because in a cube, everything is going to be the same. So this must be 5. Now, the issue is I don't know what A to G is, and I don't know what the length of A to C is. And I need something else because with trigonometry, I need 2 sides and an angle, okay? And I've only got an angle and a side, which means I've got to use a second triangle, ABC, this triangle. So ABC, A to B to C, and I know that I've got a right angle here because 2 edges meeting at 90 degrees at the point B. I know that AB is 5 centimeters. I know that BC, because it is a cube, must also be 5 centimeters. And now I can use Pythagoras to work out my length A to C, which I'm going to go and call length Y. And again, don't let these letters here, these letters of the corners of the triangle, confuse you with Pythagoras or trigonometry. It's just taken right from labeling the triangle in my diagram to make things really clear which sides I'm referring to. Okay? Because if I go and get my length A to C, I can put it back in my length A to C down here and make it really clear this is a G up here. So if I get AC, I can use it down here. But this triangle up here, right, this is actually going to be using Pythagoras because I want to find this side, my hypotenuse, C, and I've got my 2 shorter sides, A and B. So I'm using Pythagoras first, and then I'm using trigonometry. So actually this stuff, if you've watched my previous video on Pythagoras in 3D, we've seen before. So Pythagoras, we can say that A squared plus B squared is equal to C squared. Because again, Pythagoras, this stuff, is where you're given 1, 2, 3 sides, okay, which I've got here. I know that A is 5, so it's going to be 5 squared plus B squared, well, B is also 5, so plus 5 squared again, is equal to my missing side, C, which I've called Y, so equal to Y squared. So 5 squared is 25, add 25 is equal to Y squared, so 50 is equal to Y squared, so Y is going to be equal to the square root of 50. And because I want to use now my length Y, which is the length A to C, okay, I want to use it again. I'm not going to put this into my calculator because I might get a rounding issue later on. So I'm going to keep it as root 50. And I now know that A to C, which is this side here, has got a length of root 50 centimeters. You could put it as a decimal. I like to keep things in exact value form. okay? But this is good now because I've now got this triangle where I've got two sides and I'm trying to find a missing angle, which is here, which means now I'm using trigonometry, SOHCAHTOA at the grade 5 level. And with this stuff, we label up our triangle with regards to the angle, which is here, the side opposite the angle. This is always the opposite side, O, and then my longest side, always opposite the right angle, is hypotenuse. But I always say, if there's nothing there, leave it blank, okay, and this must be the adjacent side, A. I could label that H, but I always say to my students, when I teach this, where there's no information on this side, leave it blank, because now it's really clear. I've got O and A. Which one of these has got both O and A in it? It's going to be the TOA part, okay, because I've got O, I've got A, I've got O, I've got A, which is good. I'm trying to find the angle, this one here, which is angle CAG. So what I do is I put my finger over the angle part of the formula, which is this part, and say that tan of the angle, so tan of the angle, this just means angle, is equal to the opposite side divided by the adjacent side. So O divided by A. And it's really important I write out my formula, because once I get the right formula, it's just a case of substitution. I can say that tan of my angle, well, the angle is what I'm trying to find. That's the missing angle. So let's go and call that X, because that's what I called it. So tan of the angle X is equal to the opposite side, O is equal to 5. So 5 over the adjacent side, A is equal to the square root of 50. Okay. Now I'm trying to find X. To find X, this is where I've got to go and do the tan inverse. So when you find angles in trigonometry, you do the inverse of the trig function. So you do that tan inverse, and then this part, which is 5 over root 50. And then we put this into our calculator. Okay, so if you've got one similar to mine, if you've got a Casio, which I think are the best calculators, we go shift, you then go on your tan function, we go on to the fraction, and we go 5 over root 50, and then close the bracket, and then press enter, and we get 35.3 to one decimal place. So 35.3 degrees to one decimal place, because angle X, remember this, okay, is angle CAG. Yeah, I've called this angle X. Okay, sorry, CAG. It's this one, isn't it? Angle X. So there we go. This is angle CAG, and let's highlight this. There we go. 35.3 degrees. So I had to use Pythagoras first to find my length AC, to then go and use a bit of trigonometry. Good. Example 2. This one is saying find angle DCF. So let's go and draw this in. So I've got this triangle. So D to C to F. And again, the middle one is what you're trying to find. So this angle at the point C. So this triangle over here, I've got the point D, which is down here. I've got the point C, which is over here. I've got the point F, which is up here. Good. And I'm trying to find this angle, so let's go and put this in here, and let's go and call this again angle X, a missing angle. What do I know here? I know, what do I know? I know, well, that's this length here, E to F, is 10 centimeters, which must be the same as C to D, because they're the same edges in the triangular prism. So C to D down here is 10 centimeters. Now again, it's going to be tricky because I've got a missing angle, but I've only got one other side to help me get there. I need either this side or this side. So I've got to use a second triangle, and I can do that by using this triangle, BD to F, right, where I've got B is here, D is up here, and F is here. I've got a right angle at this point, so I should draw that down here as well. And on this triangle, I've been given angle B, which is 20 degrees. I've been given B to D, which is 7 centimeters, which is nice. Okay. And now I've got a choice, right? I can either go and find, well, I could go and find B to F. I could get this and go and call this X. Would that be useful? No, not really, because that would be finding this side here, which is not on my red triangle. So that's a bad side to go and get. But if I find F to D and call this, not X, sorry, I've already used X. Let's go and call it missing side y, well, f to d is down here. FD would be very, very useful. Okay? So it's going to be a double trigonometry problem. So let's go and begin by looking at the first triangle, BDF. I've got this angle here, side opposite the angle we call the opposite side. And again, don't let B, D, and F confuse you with trigonometry. I'm just labeling it from the diagram. I know that my longest side is hypotenuse, but I don't need that one because there's nothing there. And this side is my adjacent side. So again, I've got O and A, which is going to be... Oh, what's happened there? So I've got a bit of an issue with... what's happened here? Sorry. Where was I with this? Sorry, what was going on there? I'm really not too sure. Okay, sorry. I've got O and A, so I'm using this TOA formula. And I'm trying to find this side here, which is y, which is my opposite side. So I put my finger over the opposite part of the formula, and I say that O is equal to, this time, tan of the angle times by the adjacent side. So tan of the angle, theta, times by the adjacent side A. And again, really important, you just write down your formula to begin with. Now O is what I'm trying to find, which is y. So I say that y is equal to tan of the angle, and my angle is 20. So tan 20 times by the adjacent side, and A is equal to 7. So now I go and say my missing side y. I could have called that anything, but I've just called it y. And I go and type this into my calculator. So I've got tan of the angle 20, close the bracket, brackets are really important there, timesing it by 7. If you don't close the bracket and you write something like this is very, very different. You've got to close the bracket after that 20, type in 7, and then we go and get it to be 2.547, and this time, right, don't round it too early because I don't want to get any rounding issues. So I'm going to use quite a few places. So 2.54779. So 2.54779 centimeters. Does that make sense? Yeah, it seems okay because, right, you've got this side 2.5 with a small angle. Seems pretty reasonable. Okay, so I found this. So I know that length y, okay, which is f to d, f to d, which is down here, has got a length of 2.5477. So let's go and write in 2.5. I'm just going to go and write 2.5. I'm going to use all of the places when I use it in the question. Now this is good because I've now got a triangle where I've got a missing angle, which I'm trying to find, with two other sides, which means I can use trigonometry again, which is good. Okay, so let's go and do that. Again, let's go and label up our triangle. So I've got my angle, which is here. Opposite side to the angle is going to be my opposite side. Again, that's my hypotenuse, but there's nothing there, so leave that blank. And I've got my adjacent, which is here. Again, right, it's going to be using this equation triangle, TOA. Okay, but I'm trying to find the angle this time. So I put my finger over the angle part, which is this part, and I say that tan of the angle is equal to the opposite divided by the adjacent. So O divided by A. Really important I write the equation I'm using down. And then just a case of putting in my value. So tan of the angle, well, the angle is what I'm trying to find, which is x, is equal to the opposite side, which is 2.54779. And I divide that by the adjacent side, which is 10. Again, I'm trying to find the angle. So with trigonometry, this is where I do the inverse function. So tan inverse of this, 2.54779 over 10. And you can see I'm writing out all of my working. It's really, really important because if I do make a mistake somewhere, okay, in an exam, you're getting all of the marks for the working, which is really, really important. Let's clear this and let's go again, shift and then tan. And then let's put in my fraction button and say I've got 2.54779 over 10. Close the bracket and I get an angle of 14.3. So 14.3 centimeters, and that is to 1 decimal place. So this angle X, which is angle DCF, okay, so that means angle DCF, which I've just labeled X, is 14.3 centimeters. Okay, so that is my answer. So this question was a case of using trigonometry twice to get to what I needed, but all good. Okay, now you can try a couple of questions yourself. What I would do is I will go through them one by one. So I'll look at question 1 and question 2. I will write up the answers here and over here, part A, B, and C. And you can fast forward to the end of the video to check your answers. And if you get stuck at any point, you can just rewind to where I am on the video. So question 1, it says find the angle C to E to G. So let's go and draw the triangle in CE and then G down here. Okay, so I'm trying to find angle CEG. E is the middle one. I want to find this part over here. I've got a right angle over here. So again, I've got GEC. Let's label up our triangle. So I've got G, E, and I've got C up here. I've got my right angle at the point G. I'm trying to find this angle. So let's go and call this missing angle X. That's what I'm trying to find. I know, what do I know? I know that my length is G to C. This is 4 centimeters, but I don't know what E to G is, and I don't know what E to C is. So I've got to probably go and find another missing side. I can do that by looking at triangle EH and G up here, because on this triangle, E to H to G, I know what E to H is, because it's 7, so 7 centimeters. I know what H to G is, which is 3 centimeters. And if I go and work out my side E to G, and that's going to call this missing side Y. You could call it anything, but I'm going to call it Y. If I get this E to G, I can go and put it into this down here. Okay, but be careful here, because this triangle, the green one, is 3 sides. 1, 2, 3 sides. 3 sides is Pythagoras. Okay, so it's going to be labeling a triangle with Pythagoras. So longest side, which is C, opposite the right angle. 2 shorter sides, A and B. So it's going to be Pythagoras to begin with. So back to your A squared plus B squared is C squared stuff. Okay, where A is 7, so 7 squared plus B squared, well B is 3, so plus 3 squared equals to C squared. I've called that missing side Y, so Y squared. So 49 plus 9 is equal to Y squared. So 58 is equal to Y squared. So Y is going to be equal to the root of 58. Okay, and Y is that side E to G. So let's make that really clear. Y is your side E to G. What I could do is I could put this as a decimal. Again, I'm going to leave it as an exact value because you're less likely to get any rounding issues there. So I know that EG is root 58 centimeters. Okay, and now this triangle is going to be trigonometry because I've got a missing angle with my opposite side and my adjacent side. Okay, so it's going to be again the TOA part of this, and I'm trying to find the missing angle. Okay, and that part is this part of the formula, so it's going to be, I write the formula out, I'm trying to find this part, so I say that I've got tan of the angle is equal to the opposite side divided by the adjacent side, so O divided by A. So I've got tan of the angle, which is X, that's what I'm trying to find, is equal to the opposite side, which is 4, over the adjacent side, which is root 58. And again, you could put this bit as a decimal, but I'm just putting it as a third. I'm going to have to go over here for some more room. Again, I've got to find the missing angle X, so I've got to go and take the tan inverse now of 4 over root 58, and then put this into my calculator, and let's see what I get. So let's do that over here. Let's refresh this and say I've got a shift tan fraction 4 over the square root of 58, and then let's enter that, and I get 27.7 to 1 dp, so 27.7 degrees, which is this angle CEG. So this is angle X, okay, which is angle CE to G. And let's highlight the answer, there we go, 27.7. Brilliant. So that is the first answer. So let's go and put that into our first page. So this angle, put it into a pen, 27.7 degrees was the first answer. Good. Okay, let's have a look at question 2. So 3 parts here. First of all, the first part is saying work out length FD. So FD is here. Okay, so we're looking at this triangle. We've got B to D to F, where here's my right angle. So I've got B to D to the point F, where my right angle is at the point D. I want to work out the length F to D. So that's going to call this missing length X. What else do I know? I know that my angle is 20 degrees, and I know that B to D is 9 centimeters. And this is going to be trigonometry because I've got an angle with 2 sides, so it's going to be labeling a triangle with SOHCAHTOA stuff. So it's going to be angle opposite side is O, and I've got my adjacent side again. Okay, so it's going to be the TOA because I've got O and I've got A. Now, I'm trying to find X, which is the opposite side. So you put your finger over O, and you say that the opposite side, it's going to be a bit cramped, isn't it? O is equal to tan of the angle times the adjacent side. So tan of the angle theta times the adjacent side. Well, O is what I'm trying to find, which is X. I'm substituting in my values now, equal to tan of the angle, which is 20 times the adjacent side, which is 9. So there we go. Put this in my calculator, sorry, and I say that X is equal to tan 20 times 9. Let's go and whack that in. So let's go over here and say I've got tan 20 times that by 9, enter it, and let's not round too early here because we might get some issues. So let's go for 3.2757. So 3.2757, which you could say to 1 decimal place, right, is going to be 3.3 centimeters. Okay, that is to 1 dp. And let's go and highlight this answer. So 3.3. There we go. But I'm guessing I'm going to have to be using this in part B and C, which is why I've kept it long also over here. Part B is saying this, work out the length C to B. So where's that? CB is this triangle. So CB, I can use this. Okay, let's put it over here. So I've got point A, which is my right angle. So I've got A, C, and then to B, where here is my right angle. What do I know here? What have I found? I found FD. Is that going to be useful? Not for this, no. But I know that E to F is 25, which must be the same thing as A to B, because they're the same edge, effectively. So AB is 25 centimeters. What else do I know? I know that A to C must be the same thing as B to D, because they're the same edge, again, effectively. So AC must be 9 centimeters. I'm trying to find the length CB, which is good, as C to B, which is here. So let's go and call that missing side length side Y. I've already used X, so let's go for Y over here. And this time again, I've got 3 missing sides. This is actually going to be Pythagoras. Okay, so not SOHCAHTOA. This is going to be your ABC stuff. So longest side, which is C, 2 shorter sides, A and B. And now we're using a bit of Pythagoras. So it's going to be A squared plus B squared is equal to C squared. A is this side, which is 25 squared, plus B. B is 9, so plus 9 squared is equal to C, or C I've got one called Y, so equal to Y squared. 25 squared is 625, I believe. 625, let's double check that. Don't want to make any silly mistakes. 25 squared, it is 625, good. Plus 81 is equal to Y squared. Let's go and add these together now. So 625 add 625 and 81 is 706. So 706 is equal to Y squared. So Y is going to be equal to the root of 706. Okay, so now it's going to put that into the calculator. Again, I will leave my answer as root 706, but just in case you didn't, let's now go root 706. Okay, which as a decimal, you might have gone 26.6 to 1 dp. So 26.6 ... Anyway, I'm going to leave my answer as this, okay, root 706, just because I might have to use it later and I won't get any rounding issues. If it said give it to 1 decimal place, then you would use the one below. Okay, so these are both going to be in centimeters and centimeters. Okay, so that's part A, part B. So part A was up here, part B was this part, and then part C, last but not least, is to work out the angle CBE. So CB is there. Let's use this triangle. So it's important that we get the right triangles here, where I've got a right angle at the point C. So I've got this point down here, which is, let's go and use red, sorry. So I've got this point C. I've got E, which is up here, and I've got B, which is down below here. Now I'm trying to find angle CBE, where the middle one is what you're trying to find. So if my triangle is CBE, I want to find this angle here. I've used X, I've used Y, let's go and use, Z looks a bit like a 5, so let's not use that, let's go and use angle K, okay? Angle K. But you can call it whatever you want to, don't let that confuse you. I've just called it missing angle K. In fact, let's just go and call it theta, otherwise that might overdo it. Theta. So this angle, B, is what I'm trying to find, okay? And what do I know here? I know that I can use this length, C to E, because I've got F to D, wasn't it, in the first part, which was this, okay, X, which was 3.2757. So I was going to use that. So EC is going to be 3.2757 centimeters, because remember in the first part, I should have made that clearer, the X, that is your missing length, FD. Good. What else have I got? Have I got length CB? I have. Sorry, in part B, I got this length C to B, which we knew from over here. Again, I should have made it a bit clearer that Y, it is your length C to B. So Y is CB. So I can use that length C to B over here, which is equal to root 706. So root, oh, it's very cramped, isn't it? 7. In fact, let's write it up here. Root 706. Good. And now I've got trigonometry because I'm trying to find a missing angle, and I've been given 2 sides. So it's going to be trig. Okay, I've got my angle opposite side, and I've been given my adjacent side, A, once again. So it's going to be using TOA. I'm trying to find the angle part, so put your finger over the angle part and say that you've got tan of the angle is equal to the opposite side divided by adjacent, so O divided by A. So I've got tan. The angle, I've just kept it as theta, so that's what I'm trying to find. Tan of the angle theta is equal to my opposite side, which is this. So 3.2757. I'm not rounding too early, otherwise you might get rounding errors. Over the adjacent side, which I've kept as root 706. So theta is going to be the tan inverse of all of this, so 3.2757 over root 706, and then whack this into your calculator, okay, really carefully, particularly as we're getting quite late into the video. Bit of brain fatigue, we go shift, we go tan, and then let's put this up here. We've got 3.2757 over root, you could write here 26.6, I'm keeping it as 706, and let's go and press this, and we get 7.0, so just 7 degrees, okay? So 7.028, so I'm going to keep it as 7 degrees, okay, to 1 dp, or 7.0, yeah, so 7.0 degrees. So this is our final answer. Okay, so this angle, which I've called theta, angle CBE. Let's make that really, really clear. So we've got pen, we've got angle CBE is equal to 7 degrees. So I'm just going to put this into our answer box. So 3.3 and root 706 and 7. And I've already put in 3.3 root 706. So we've got 3.3 root 706, and then angle was 7 degrees. But again, part B, you could have also put that being equal to, what was that equal to? Let's have a look. 26.6. Okay, because it didn't actually specify what it wanted. Right, root 706, which is approximately, 26.6. 26.6. And lengths are going to be centimeters, length, centimeters, and angle. Okay, so here are all of your answers. So part A, there we go. In fact, let's highlight them. So, well, you can see them yourself, right? So 3.3 for A, B, root 706 or 26.6 centimeters, and C was 7 degrees. Okay, and of course, at any point you can rewind the video and check your answers, but these are your answers for those questions. If you got those correct, really, really well done, because, you know, there is quite a lot going on there. But I do believe if you build things up, there is no reason why you can't be doing this stuff. But well done. Bit of a long video, that one. But thank you for watching.